Okay. So in the last lecture, we have started about the internet protocol. Protocols means we know that there are some rules that are defined that what should be the syntax of the message, what type of message should be exchanged between the source and destination to provide the guaranteed delivery of the data. Okay. So the first common protocol, or we can say the primary protocol of the network layer, is IPv4. So this IPv4, the full form is Internet Protocol version 4. The current version of this protocol is version 4. So it is the delivery mechanism used by the TCP/IP protocol. So whenever you want to deliver your message from one hop to the second hop, or we can say that one router to the another router, at that time you require the packet. You require the packet. So what should be the format of the packet? What type of information you have to add in your packet? So this all type of information can be provided by this IPv4 protocol. Okay. For example, we can relate this with our post office. Okay. Suppose આપણે કોઈને કઈ લેટર મોકલાવો હોય, કોઈને કઈ મેસેજ મોકલાવો હોય, તો what we'll do? તો પહેલા તો આપણે એક લેટર લઈએ અને એન્વેલોપ ની અંદર મૂકીએ. એન્વેલોપ પર આપણે ટુ અને ફ્રોમ, ઓકે, આપણું પોતાનું એડ્રેસ, જેને મોકલાવાનું છે એનું એડ્રેસ લખીએ. ઓકે, એન્ડ ધેન વી વિલ પ્રોવાઈડ સમ, લેટ્સ સે કે આપણે કોઈ હિન્ટ આપીએ એન્વેલોપ પર કે if you are go with this route, then you can have a shortest path. Okay, so this type of mechanism can be implemented in network by this protocol. Okay, so protocol is nothing but when we are sending some message, so what should be the format of that message, that can be defined by the protocol. Okay? So the most common protocol of this network is IPv4. Okay, so IPv4 is responsible for packetizing, forwarding and delivery of a packet at the network layer. Okay, so તમારું પેકેટ ને ક્રિએટ કરવાનું અને ફોરવર્ડ કરવાનું અને ડેસ્ટિનેશન સુધી ડિલિવર કરવાનું, that all tasks can be done by this IPv4 protocol. Okay, so we can say that here we have seen the diagram in which on the network layer we are using the four protocol: IP, ICMP, IGMP and ERP. So this IP is a primary protocol. Okay, that is, we can say it is the main protocol of network layer, while we can say that ICMP, IGMP and ERP, these are the secondary protocol. Secondary protocol, or we can say the supplementary protocol of IP protocol. Okay, that means everything can be done by the IP, but let's say some supplementary service can be provided by ICMP, IGMP and ERP. Okay, so delivery of the message can be done by the IP, but there is a protocol called ICMP, Internet Control Message Protocol. Okay, so as the name suggests, controlling the message. That means if that is some errors going to be generated during the delivery, so such type of error can be handled by the ICMP. We will see it in a detail, that is ICMP. Then IGMP, Internet Group Message Protocol. So when we have task of multicasting, at that time we can use the IGMP. Okay, and the fourth one is ERP, that we have already learned, Address Resolution Protocol. So the task of ERP is to just perform the mapping from IP address to the, we can say IP address to the MAC address. So we can say that ERP, the task of ERP is to just perform the network layer address to the data link layer address. Okay, so we will learn all this protocol in detail. Okay, on the same way on the transport layer we have the HTTP, TCP, UDP, that we learn in the transport layer, and same way on the application layer we have the so many another protocols, so that we learn in the application layer. Okay, so IPv4 is an unreliable datagram protocol. Okay, so unreliable means it may possible that your packet can be lost, or it may possible that packet can be corrupted, packet may be arrived out of order, or it may possible that the packet will create the congestion. So this all type of delivery can be known as the unreliable delivery, in which we have the no guaranteed delivery of your data. Okay, so who is responsible for reliability? So we can say that if you want to achieve reliability, then you need to combine your IPv4 with the upper layer protocol. Okay, so network layer ની ઉપર છે આપણું transport layer. Transport layer where we have the TCP and UDP. So TCP is a reliable datagram protocol. So when you require the guaranteed delivery of your data, at that time you need to combine TCP with the IPv4. Okay, So you can assume that let's say, or in the post office, okay, so suppose આપણે કોઈ letter મોકલાવીએ છે, okay, so the post office will try their best to send our letter, okay. આપણો જે કંઈ પણ જેને લેટર મોકલાવાનો છે તેના સુધી આપણો લેટર પહોંચાડવા માટેની એ post office will maximum try, okay, post office will do their maximum try, okay, but it may possible આપણે ઘણીવાર જોઈએ છે કે તમારો લેટર જેને મોકલાવા માંગો છો ત્યાં સુધી પહોંચતો નથી, ઓકે, જે કંઈ પણ ડોક્યુમેન્ટ તમે મોકલાવા માંગો છો તે ઘણીવાર રિસીવર સુધી પહોંચતું નથી પોસ્ટ ઓફિસમાં, ઓકે. So this type of delivery can be known as the unreliable delivery, okay, in which we know that જે કંઈ intermediate જે protocol છે like our post office છે, so that will trying their best to deliver your document, but it may possible that due to some problem they are not able to deliver the document, okay. The same thing is about the IPv4, that IPv4 will try their best to deliver your data, but it may possible that due to some routing protocol or due to some let's say due to some another problem, congestion, it may not possible to deliver your data, okay. So at that time this IPv4 let's say in our post office means who is sender and who is receiver, okay. So that sender and receiver has to depend on let's say કે તમારો ડોક્યુમેન્ટ ના પહોંચ્યો હોય, that is the responsibility of the sender and receiver. જેણે ડોક્યુમેન્ટ મોકલાવ્યું છે અને રિસીવર કર્યું છે તો એની રિસ્પોન્સિબિલિટી થઈ જાય જો તમારું કંઈ પણ લેટર ડિલિવર ના થાય તો. So same thing is about the IPv4. If your data is not delivered, then it is the responsibility of the sender and receiver to find out the reason that why your data is not delivered, okay. So for that we require the TCP protocol. TCP provides the end-to-end delivery. We see that. So using that TCP we can find out that what is the reason that why your data is not delivered, okay. IPv4 is also a connectionless protocol. So as we have said yesterday that your data can be divided, your message can be divided into various packets, and it may possible that every packet will reach to the destination through the different paths, okay. બધા પેકેટ જુદા જુદા પાથથી થઈને ડેસ્ટિનેશન સુધી પહોંચે. So it is the responsibility of the receiver to combine all the packet and create a single message, okay. So it is a connectionless protocol. That means it may possible that every packet will choose the different path to reach the destination. This is about the IPv4. Okay, now IPv4 datagram format. Okay, datagram means nothing but packet. Okay, so packet that is used to deliver your data, that is known as the datagram. The network layer, it is known as the datagram. તમે જે પેકેટ નો યુઝ કરો છો તમારા મેસેજ ને ડિલિવર કરવા માટે તેને કહેવાય છે ડેટાગ્રામ. Okay, so this datagram can be divided into two parts. The first part is header and second part is data. Okay, data means તમે જે ઓરિજિનલ મેસેજ ડિલિવર કરવા માંગો છો તે, અને header means we require some extra information to find out that what type of information we have included in our data. આપણા ડેટામાં આપણે કઈ ટાઈપની ઇન્ફોર્મેશન મૂકી છે તો એ રિસીવરને ઇન્ફોર્મ કરવા માટે કે જે પણ ઇન્ટરમીડિયેટ નોડ આવે એને ઇન્ફોર્મ કરવા માટે we require the header. So headerમાં ઘણી બધી ફિલ્ડ હોય. Using that we can identify that what type of information we have added in our data. Okay, so header ની length કેટલી હોય છે? The length of header is from 20 to the 60 bytes. Okay, the length of the header can be 20 to the 60 bytes, while the length of the whole datagram can be 20 to the 65536 bytes. Okay, and based on that, if you have given the total length, if you have given the header length, then you can find out the data length. Okay, data length is equal to total length minus header length. Okay, okay. Now header માં કઈ ટાઈપની ઇન્ફોર્મેશન આવે? So first 4 bits are reserved for the version. Okay, so current આપણે પ્રોટોકોલનું વર્ઝન યુઝ કરીએ છીએ version 4. That's why these 4 bits are set as value 4. Okay, so 0 1 0 0. Okay, second 4 bits are indicated for HLN, or you can say the header length, and it is given by the 4 bits. Okay, so we know that header can be 20 to 60 bytes, or that 20 to 60 bytes means it can be up to 1 byte, that is equal to the, we can say that 8 bits. So this 600 bits. Okay, so 600 bits to the 4800 bits. So we can't that much size using the 4 bit. Okay, આપણા આટલા બીટ ની સાઇઝ આપણે 4 બીટ રિપ્રેઝન્ટ ના કરી શકીએ. So what they have done, they have divided this size by 4. Okay, so let's say minimum size is 20. So if we divide 20 by 4, then value is 5. So this 5 we can set here. Okay, આપણે આ 5 ને 4 બીટ થી રિપ્રેઝન્ટ કરી શકીએ. Let's say same way કે આપણું મેક્સિમમ હેડર ની લેન્થ છે આપણી 60 બાઇટ. तो 16 ने પણ 4 વડે ડિવાઇડ કરો और આન્સર ઇઝ 15. તો આપણે 15 ને પણ 4 બીટ થી રિપ્રેઝન્ટ કરી શકીએ. ઓકે, so whenever we want to find out the header length, what we have to do? તો hlen ની આપણી જે કંઈ પણ વેલ્યુ છે એને આપણે ફરી પાછું 5 થી મલ્ટીપ્લાય કરવાનું. ઓકે, ફરી પાછું આપણે 4 થી મલ્ટીપ્લાય કરવાનું. ઓકે, so we can get the original length of the header in bytes. For example, let's say કે header ની લેન્થ છે આપણી 60 બાઇટ. तो 16 ને આપણે 4 વડે ડિવાઇડ કરીએ और આન્સર ઇઝ 15. તો આપણે અહીંયા hlen માં વેલ્યુ સેટ કરી છે 15. ઓકે, ઓકે, નાઉ hlen પરથી આપણને કીધું છે કે હેડર ની લેન્થ ફાઇન્ડ કરી આપો. તો what we have to do? હેડર માં આપણે 15 સેટ કર્યું છે, 15 ને આપણે 4 વડે મલ્ટીપ્લાય કરવાનું. So that will give you the 60 bytes. Okay, so by that way, given the hlen per bit, we can find out the header length. Okay, next 8 bit are reserved for the service. So there are various types of service like the ICMP, okay, FTP, SMTP. Okay, so upper layer पर આપણે જે કે પણ સર્વિસ યુઝ કરતા હોય, so using that we can set this 8 bits. Okay, we'll see this thing later when we discuss about the various types of services. Okay, in the application layer. Okay? The last 16 bit are reserved for the total length. Okay, so this 65536, we know that the 65536 bytes can be represented by the 16 bits. Okay, the total length is 16 bits. Okay, so given the total length, you can find out the header length. So the header, given the total length and header length, you can find out the data length. So data length is equal to the total length minus hlen cross 4. hlen ને આપણે 4 વડે મલ્ટીપ્લાય કરવાનું. ઓકે, અને એને total length માંથી સબટ્રેક્ટ કરવાનું. total length minus hlen cross 4. Okay, so hlen ને આપણે 4 વડે મલ્ટીપ્લાય કરીએ અને total length માંથી આ વેલ્યુને સબટ્રેક્ટ કરીએ, so that will give you the data length. We will see some example. Then we have the identification, flag and fragmentation. Okay, so ઘણીવાર તમારો message is divided into the various fragments. તમારો single packet is divided into the various fragments. At that time we require this pre-fill. That pre-fill also we will see. Then we have the time to live protocol and header checksum. So time to live, or we can say TTL field, that is of 8 bits. Okay, so it may possible that due to some routing protocol, your packet can be lost within the network. Okay, due to some routing problem issue, your packet is lost within the internet. So if your packet is lost within the internet, so what is going to be happen? It may go from one router to the another router. રાઉટર 1 થી રાઉટર 2 પર ગયો, રાઉટર 2 થી રાઉટર 3 પર ગયો, 3 થી 4 પર ગયો, બટ એક રાઉટર થી બીજા રાઉટર પર જાય છે, બટ એ ડેસ્ટિનેશન સુધી પહોંચી શકતું નથી. Okay, what is the reason? Due to some routing protocol problem, or you can say due to some routing algorithm, this protocol is this packet is not able to reach to the destination. So what we can do here is, in the TTL field, we have to set the maximum number of hosts that can be visited by the packet. TTL માં આપણે we have to set the maximum number of hosts that can be visited by the packet before discarding. Okay, so for example, let's say કે there is a source and there is a destination. So source અને destination ની વચ્ચે let's say કે આપણા 10 રાઉટર છે, source અને destination ની વચ્ચે આપણા 10 રાઉટર છે. તો TTL ની વેલ્યુ કેટલી સેટ થાય? તો 10 + 10. એકવાર ડેસ્ટિનેશન પર પહોંચી જાય, ડેસ્ટિનેશન થી ફરી પાછું સોર્સ પર આવી જાય, તો તેટલા માટે જેટલા રાઉટર જોઈએ, that field is set as TTL. So let's say here that value set is 20. Okay, TTL માં આપણી વેલ્યુ સેટ થઈ છે આપણી 20. Okay, now what is going to be happen? જેવું પેકેટ તમારું નેક્સ્ટ રાઉટર પર જાય, તો TTL ની વેલ્યુ તમારી ડિક્રીમેન્ટ થાય. Okay, so 20 નું થયું 19. Then again બીજા રાઉટર પર જાય, again TTL ની વેલ્યુ ડિક્રીમેન્ટ થાય. So 19 નું થયું 18, 17, 16, 15. અને ફાઇનલી જો TTL ની વેલ્યુ જો 0 થઈ જાય, તો TTL ની વેલ્યુ જ્યારે પણ રાઉટર પાસે કોઈ પેકેટ આવશે તો પહેલા TTL ની વેલ્યુ ચેક કરશે. તો TTL ની વેલ્યુ જો 0 હોય, that indicates that this packet is corrupted and it is going to be removed from the internet. Okay, so TTL field is very important, that if your packet is we can say not reaching to the destination and it is roaming within the internet. Okay, due to some routing problem, that packet is roaming within the internet itself and it is not reaching to the destination. At that time, we require the TTL. Okay, so due to that, it also remove the congestion problem. Okay, so congestion is created due to some extra data within the network. Okay, so એવું કોઈ પેકેટ છે કે જેને એનું ડેસ્ટિનેશન ખબર નથી પડતું અને તો પણ નેટવર્કની અંદર છે, so that type of packet should be removed. So using that TTL field, we can remove such type of packets. Okay, બીજી field છે આપણી protocol. Protocol is of 8 bits. Okay, so various types of protocol can be used by the IPv4. So we have said that IPv4 is a unreliable datagram protocol. Okay, so we need to depend on the upper layer protocol, that is TCP. Okay, so suppose TCP is using the service of IPv4. Okay, TCP जो IPv4 ની service use કરતું હોય, so at that time we have to set protocol value that is equal to the TCP. Okay, so some values are already given. That is, let's say that we have the different protocol on the transport layer like the HTTP, TCP, UDP. Okay, so this all can be take service from the IP. Same way, network layer पर we have the ICMP, IGMP, OSPF. These all are taking the service from the IP. Okay, so they have set some values like the ICMP then 1, IGMP and 2, TCP then 6, UDP then 17, OSPF then 89. Okay, so for example, let's say if TCP is using the service of the IP, जो આપણો TCP protocol जो IP ની service use કરતો હોય, તો TCP માટે protocol ની value કેટલી છે? તો 6. Okay, so we have to set that 6 value in this protocol field. So using this protocol field, we can say that આપણું જે IPv4 datagram આવ્યું છે, that is the single packet or it is the part of some upper layer protocol. Okay, then we have the header checksum. Okay, so આમાંનું કોઈ પણ બીટ જો ચેન્જ થયું હોય, okay, વર્ઝન થી માંડીને સર્વિસ કે આઇડેન્ટિફિકેશન TTL પ્રોટોકોલ, તો આમાંનું કોઈ પણ એક પણ બીટ જો ચેન્જ થયું હોય, so it will create the difference on the checksum value. Okay, so જો તમારો checksum, whatever you have add the checksum at the sender side, that same checksum is not calculated at the receiving side, then we can say that there is some problem in the header length field and that packet is going to be discarded. Okay, so we will see that how the calculation can be done for the header checksum. Then we have the source IP address and destination IP address. So we have discussed that what is the format of the IP address. Then various option fields are there. Okay, so there may be some options that are required to find out that which type of traffic can be carried out by the protocol or which type of service can be used by this protocol. So this option can be of variable length. Okay, this option can be of variable length. That's why this length of this header can be various from 20 bytes to the 60 bytes. These are all about the various fields of the header. Okay. Total length field defines the total length of datagram including the header. Okay, and total length પરથી જો તમારે data length find કરવી હોય, so data length is equal to total length minus header edge length into 4. Okay. Let's take some example. An IPv4 packet has arrived with the first 8 bit as stolen. પહેલા 8 bit. પહેલા 8 bit માં we know that the first 4 bit are for version and the second 4 bit are for HLN, or we can say the header length. Okay, so they have said that the first 8 bit. Okay, so 0100 indicate the version. So our version is 124. It is correct. And the receiver will discard the packet. So receiver a packet ne discard કરે છે. So what is the reason? So we can calculate the second 4 bit as 0010. So 0010, then our value is 4. Value is 2. Okay, so we need to multiply with 4. We need to multiply this 2 with the 4. So value is 8. Okay, so it is said that our header ni length કેટલી છે? So header length is 8 bytes. Header length is 8 bytes. But we know that the header length can be 20 to the 60 bytes. Okay, header ni length આપણને મળી છે 8 bytes, but header ni length આપણી started થાય છે 20 bytes. So that's why the receiver will discard the packet. Receiver will discard the packet. Okay. If an IPv4 packet, the value of HLN is 5. HLN ની value 5 છે, તો header length કેટલી થશે? તો આપણે 5 ને કેટલા વડે મલ્ટીપ્લાય કરવાનું? આપણે 5 ને મલ્ટીપ્લાય કરવાનું 4 સાથે. તો 5 ગુણ્યા 4. 5 into 4 so 20. Okay, so header length is how much? Header length is 20 bytes. Header length is 20 bytes. HLN ની value આપી હોય આપણને, તો HLN ને મલ્ટીપ્લાય કરવાનું આપણે 4 સાથે, that will give you the header length. So header length will be 20 bytes. And the value of the total length field is in the hex they have given 28. Okay, so hex માં આપણું 28 હોય, તો 28 નું ડેસિમલ થાય આપણું 28 નું ડેસિમલ થાય આપણું કેટલું થાય? 40 bytes. Okay, so the decimal value of 28, okay, 28 hexadecimal છે, એની decimal value થશે આપણી 40 bytes. Okay, so total length આપણને hex માં આપી છે 28, so total length થશે આપણી 40 bytes. So how many bytes of data are being carried by this packet? Okay, so we know that data length is equal to total length minus header length. Total length આપણને આપી છે 40 bytes minus header length. We have calculated it as header length આપણે કેટલી calculate કરી? So header length we have calculated as 20 bytes. So 40 minus 20, 20 bytes. So the length of the data is 20 bytes. Third one, an IPv4 packet has arrived with the first few hexadecimal digits as shown. Okay, આપણને hexadecimal માં value આપી છે બધી. So let's say કે આપણો જે first 4 bit is for version, second 4 bit is for header length. Okay, then we have the 1 2. Okay, so 4 okay, hexadecimal છે मतलब એક hexadecimal bit માટે આપણને 4 bit જોઈએ. तो पहला 4 bit की नंबर बने છે આપણો 4. Okay, so that means we can say that version is 4, then the HLN is 5, so the header length is 20 bytes. Okay, then after we can say that the second 8 bit is reserved for the service. Okay, એના પછીના 8 bit આપણા સર્વિસ માટે છે. Okay, so 00 is for service. Okay, so by that way we need to answer the question. So what is the question? How many hops can this packet travel before being dropped or discarded? Okay, so કેટલા હોપ એ maximum travel કરી શકે discard થયા પહેલા? તો એના માટે કઈ field છે? So we know that field is HLN. We know that the field is time to live. That field is time to live. We know that maximum કેટલા હોપ visit થઈ શકે. So for that our field is TTI. So we need to find out that what is the value of TTL. Okay, what is the second question? That the data belong to what upper layer protocol? Okay, so data belong to what upper layer protocol? Okay, so here આપણી જે TTL field છે તે કેટલા hexadecimal number પછી આવશે? So this is our first hexadecimal number. આપણો બીજો hexadecimal number 3 4. Okay, આ બીજા બે hexadecimal number થઈ ગયા. 1 2 3 4. Okay, 5 6 7 8. Okay, 9 10 11 12 and 9 10 11 12 13 14 15 and 16. તો આપણા 16 hexadecimal number પછી આપણને TTL field મળશે. Okay, so we count the total 16 hexadecimal number. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. Okay, so 16 hexadecimal number પછી આપણને TTL field મળે છે. TTL field કેટલા બીટ ની છે? તો આપણી 8 બીટ ની છે. 8 બીટ मतलब આપણા 2 hexadecimal number. So this 01 indicates the TTL field and 02 indicates the protocol field. 01 indicates the TTL field and 02 indicates the protocol field. So આપણું 01 indicate કરેલું છે, that means the packet can travel on the one hop. એક હોપ સુધી જાય એના પછી એ discard થઈ જાય. Okay, and 02 indicate the protocol field. So we have seen that 02 we are using for the ICMP. So we can say that this protocol is used by the ICMP protocol. Okay, we can say that this IPv4 packet belongs to the ICMP upper layer protocol. Okay, So this type of example can be asked. So for that you need to remember the syntax of this IPv4 datagram format. Now one more question. We have seen the all the fields, but we have neglected three fields, that is identification, flags, and fragmentation offset. So I have said that these three fields are used for the fragmentation. So what is the meaning of fragmentation? Before that, we need to define one term, that is MTU, maximum transfer unit. Okay. So when a datagram is encapsulated in a frame, okay. So જ્યારે આપણો datagram or packet આપણું network layer પરથી data link layer પર જાય, at that time this whole datagram is encapsulated in the frame payload. Frame ના payload માં આપણું આખું આ datagram આવી જાય. Okay, અને પછી data link layer છે પોતાનું header ને પોતાનું tailor add કરશે. Okay. So when a datagram is encapsulated in a frame, the total size of the datagram must be less than this maximum size, which is defined by the restriction imposed by the hardware and software used in the network. Okay. So it should not be like that. Suppose આપણો આખો IP datagram છે એ 1000 bytes નું છે. This whole IP datagram is of 1000 bytes and the size of this frame payload is only 500 bytes. આપણું આખું IP datagram આપણું 1000 બાઇટ નું છે અને જે ડેટા લિંક લેયર પર આપણી ફ્રેમ ક્રિએટ થાય છે એમાં જે ફ્રેમ પેલોડ છે એ ખાલી 500 બાઇટ નો છે. So we cannot add the whole IP datagram in the frame payload. So we require the restriction that what should be size of this frame payload or what should be size of this IP datagram, so that we can easily add this IP datagram in the frame payload. So this MTU defines the size of this frame payload. Okay. So it can be dependent on the types of the network or dependent on the hardware and the software. Okay. So depending on the network, this frame payload size can be different. Okay. And so depending on this frame payload size, the size of the IP datagram should be also vary. So they have defined that the value of the MTU differs from one physical network protocol to another. For example, the value for a LAN is normally 1500 bytes, but for a WAN it can be larger or smaller. Okay. For example, if we are talking about the LAN, okay, suppose if your data is passing through the 5 LAN, so for each LAN, the size of this frame payload can be 1500 bytes. But when your data is passing through the combination of LAN and WAN. When the data is passing through the combination of LAN and WAN, so it may possible that frame payload is also going to be differentiated. Okay. So for example, LAN માટે 1500 bytes છે, so it may possible that for WAN it can be the larger or smaller. So what they have done that the maximum length of the IP datagram that should be equal to the 6553 bytes. Fixed. Okay. IP datagram size, we have seen that they are fixed at 65535 bytes, which is efficient if you use a link layer protocol with an MTU of this size. Okay. આપણે MTU, we can say that frame payload use created that is of 65535, then the size of this IP datagram must be 65535 bytes. Okay. So for other physical network, so જો આપણે આટલા જ બાઇટ નું જો MTU યુઝ કરતા હોય, if we are જો આપણે IP datagram ની સાઇઝ રાખી છે 65535 બાઇટ, ઓકે, અને ફ્રેમ પેલોડ પણ જો આપણે 65535 બાઇટ્સ નો યુઝ કરતા હોય, so it is efficient or we can say it is sufficient. But આપણો જે IP datagram છે that is of 65535 bytes અને જે frame payload છે that is of only 1500 bytes. Our frame payload ખાલી 1500 bytes નો છે. So what we have to do? We need to fragment this IP datagram. We need to perform the fragmentation of the IP datagram. मतलब આપણો જે single packet છે એને અલગ-અલગ fragment માં divide કરવાનું and that single fragment is added in the frame payload. Okay. So for other physical network, we must divide the datagram to make it possible for it to pass through this network, and this is called fragmentation. Okay. So જ્યારે frame payload આપણો 65535 કરતા ઓછો હોય, કે જે આપણો frame payload ની size 65535 કરતા ઓછી હોય, at that time we need to divide our this IP datagram into the various fragments. Okay, and each fragment is added into the frame payload. So this process is known as the fragmentation. Three fields in the IP datagram related to the fragmentation, that is identification, flag, and fragmentation offset. Okay. So the 16-bit identification field identifies the datagram originating from the source host. Okay. The combination of the identification and source IP address must uniquely define a datagram as it leaves the source host. Generally, it is a one type of counter value that is set by the source. Okay, and we can say that જ્યારે આપણે fragmentation perform કરીએ કે આપણે if we are dividing your packet into the 5 fragments, so this identification value must be copied to the all fragments. receiver બાજુ પણ આપણે ખબર પડવી જોઈએ કે આ એક જ પેકેટના બધા અલગ-અલગ પાર્ટ છે. Okay, so for that we require this identification field. Okay, so the identification field, identification value source એ decide કરી હોય, that same identification value is copied to the all fragments. જેટલા પણ fragment આપણે create કરીએ તો બધા fragment માં we need to copy this identification field. Okay, so that at the receiving side we can identify that this whole fragment belongs to this single packet. Second is flags value. Okay, so we are using the 3-bit flag. Okay, we know that we have the 16-bit for the identification, 3-bit for the flag, and 13-bit for the fragmentation offset. Okay, so 3-bit આપણા flag ના છે. So what this 3-bit will suggest? So this in this 3-bit, the first bit is resolve. The second bit is do not fragment. Second bit is do not fragment. So if this bit is set as 1, then we don't perform any fragmentation. Okay, but if this field is set as 0, so આપણો આ bit જો 0 set થયો હોય, it indicates that we need to perform the more fragment. Okay, then M indicate the more fragments. M indicate the more fragments. So these fields are used to identify that it is the last fragment or not. આપણું last fragment છે કે in between fragment છે, તો identify કરવા માટે we require this more fragment bit. Okay, so M is set as 1, so it indicates that we can have a more fragment. Okay, so it can be the first fragment or the intermediate fragments, and if this M bit is set at 0, so this indicates that this one is the last fragment. Okay, so for example, let's say this third field is fragmentation offset field. So it defines the relative position of this fragment with respect to the whole datagram. Okay. For example, here we have the packet or the datagram that is starting from the byte 0000 and it is ending on the byte 3999. Okay, so let's say we have the 4000 bytes datagram. Okay, now how the offset can be calculated? Now offset શાના માટે use થાય? So the use of this offset is તમારું packet or તમારું fragment ક્યાંથી start થાય છે, so that you can identify using the offset value. Okay, so how the offset can be calculated? So you need to divide your byte by 8, and whatever value is there, that you have to set in the offset part. Okay, for example, here your packet is starting from the byte 0000, so you have to divide this 0000 by 8, so you have the value 0. That means it is said that your packet is starting from the byte 0000. Okay, now for this one, if you have divided this packet into 3 fragments, okay, so પહેલું fragment છે આપણું 0000 થી લઈને 1399, 2000 ના 3 fragment માં આપણે divide કર્યું છે. Okay, second is from 1400 to the 2799, and third fragment is from 2800 to 3999. Okay, so offset માં આપણે કઈ વેલ્યુ સેટ કરવાનું? તો offset કઈ રીતે કેલ્ક્યુલેટ થાય? તો આપણી જે પહેલી બાઇટ છે એને 8 વડે ડિવાઈડ કરવાનું. સપોઝ પહેલા ફ્રેગમેન્ટ માટે ઓફસેટની વેલ્યુ હશે આપણી 0. બીજા ફ્રેગમેન્ટ માટે ઓફસેટની વેલ્યુ હશે આપણી 1400 ને ડિવાઈડ કરવાનું આપણે 8 માટે 8 થી. તો our value is 175. તો રિસીવર બાજુ જ્યારે પણ આવું ફ્રેગમેન્ટ આવે છે તો રિસીવર શું કરશે? તો રિસીવર will extract the value of the offset. રિસીવર શું કરશે? તો ઓફસેટની વેલ્યુ એક્સટ્રેક્ટ કરશે. તો સપોઝ અહીંયા એને ઓફસેટની વેલ્યુ મળી છે 175. ઓકે, તો 175 ને 8 વડે મલ્ટીપ્લાય કરશે તો 1400. તો રિસીવરને ખબર પડશે કે your packet is starting from 1400. Your fragment is starting from 1400. Same way અહીંયા ઓફસેટ કેટલું થશે આપણે? તો you need to divide this 2800 by 8. So value is 350. ઓકે, તો રિસીવરને આવું કોઈ ફ્રેગમેન્ટ મળે છે તો રિસીવર શું કરે છે? તો ઓફસેટ વેલ્યુ એક્સટ્રેક્ટ કરે છે. ઓફસેટ વેલ્યુ છે આપણી 350. તો 350 ને 8 વડે મલ્ટીપ્લાય કરે છે. Our value is 2800. So receiver will know that your fragment is starting from 2800. Okay. So by that way, receiver can find out that at which byte the fragment is going to be started, and using that, the receiver can also combine the all three fragments to create the single packet. Okay. Let's say take one detailed fragmentation example. Okay. So this 4020 indicates the length, total length. Total length is 4020. Okay. Bytes are from 000 to 3999. Okay. So 4000 byte નો આપણો ડેટા છે અને 20 બાઇટ નો આપણો હેડર છે. ઓકે, 4000 બાઇટ નો આપણો ડેટા છે અને 20 બાઇટ નો આપણો હેડર છે. તો ટોટલ લેન્થ કેટલી થઈ આપણી? 4020. ઓકે, એની આગળ બીજા બધા ફીલ્ડ છે. ઓકે, so that we will neglect. Okay, then after this field are indicating that fragmentation identification number. Okay, this 8 bit are used for the identification number. So identification number standard એ નાખ્યો છે 14567. Okay, then we have this 3 bit are reserved for the flex. Okay, so it is set as 0. So 0 indicates that more fragmentation. Okay, 0 indicates the more fragmentation. And this offset કેટલો થશે? તો આપણે 000 ને 8 વડે ડિવાઈડ કરવાનું, value is 000. So this is set in the offset. Now we have divided into the three fragments. The first fragment is from 000 to 1399. બીજું છે આપણું 1400 to 2799. ત્રીજું છે આપણું 2800 to 3999. Okay. So what should be size? The size should be આપણું કેટલાનું છે આપણું? Okay. So 1400 નું આપણું ડેટા છે અને 20 bytes નો આપણું હેડર છે. So size of the total length is 1420. Okay. Identification number આપણો કોપી થશે ત્રણ ફ્રેગમેન્ટમાં 14567, 14567, 14567. One indicate that no more fragments. One indicate the more fragments. One indicate the more fragments. Okay, so here 0 means no more fragments. So this is the last fragment. One indicate the more fragment. That means we can have a multiple fragments from this fragment are also possible. Okay, 1 means more fragment. Okay, and 0 means this is the last fragment. So no more fragment are possible. Offset કેટલું થશે? તો આપણે 000 ને 8 વડે ડિવાઈડ કરીએ. Offset is 000. 1400 ને 8 વડે ડિવાઈડ કરીએ. Offset is 175. And 2800 ને 8 વડે ડિવાઈડ કરીએ. Offset is 350. Okay. ફરી પાછું આ જે 1420 છે એને બે ફ્રેગમેન્ટમાં ડિવાઈડ કર્યું છે. ફ્રેગમેન્ટ 2.1 અને ફ્રેગમેન્ટ 2.2. Okay. Fragment 2.1 is from 1400 to 2199. And the fragment 2.2 is from 2200 to 2799. Okay, identification number आपलो same रहेगा 14567, 14567. Okay, so we can say that 1 means more fragment, 1 means more fragment. Offset કેટલો થશે આપણો? 1400 ને 8 વડે ડિવાઈડ કરીએ 175, 2200 ને 8 વડે ડિવાઈડ કરીએ તો 275. Okay, so by that way we can create the fragmentation. We have given some example. A packet has arrived with an m-bit value of 0. Okay, m-bit is 0. This indicates that m-bit is 1. Then we have the more fragment. and m bit is 0, then no more fragment. Okay, so if the m bit is 0, then you have to say that is this the first fragment, last fragment, or a middle fragment. જો આપણું m bit જો 0 હોય, then indicate that there are no more fragments. That means this one is the last fragment. Do we know if the packet was fragmented? So that we can know, that we cannot say. Okay, એ આપણે કયા બીટ પરથી કહી શકીએ? તો આપણે d bit પરથી. Using this d bit, we can say that can we have a more fragment or not. Okay. So we cannot say that whether this packet was fragmented or not. Okay. The packet has arrived with a m bit value of 1. Is this the first fragment? Okay, so this example we have seen. The packet has arrived with an m bit value of 1 and a fragmentation offset value of 0. So is this the first fragment, the last fragment, or a middle fragment? Offset value ni 0 hoy, that means it indicates that 0 ne આપણે 8 વડે multiply કરીએ, then your fragmentation is starting from 0 0 0 0. Okay, m bit is 1, that means we can say that it can be the first fragment or it can be the middle one. Okay, m bit 0, then it can be the last fragment, but m bit jo 1 છે, then it can be the first fragment or the last fragment. Okay, but offset value આપણી 0 છે, so we can say that this is the first fragment. The packet is arrived in which the offset value is 100. What is the number of the first byte? Okay, so offset આપણું 100 છે. આપણે first byte જાણવું હોય તો શું કરવાનું? 100 ને 8 વડે multiply કરવાનું, so that will give you the first byte. So 800 is our first byte. Do we know the number of last byte? That we can't say. આપણને last byte ખબર ના પડે, એના માટે આપણને fragment ની size ખબર હોવી જોઈએ. A packet is arrived in which the offset value is 100. The value of HLN is 5 and the value of total length field is 100. What are the number of the first byte and the last byte? Okay, આટલું બધું આપ્યું હોય, then we can say that what is the number of first byte and what is the number of last byte. Okay, so offset છે આપણો 100, એને 8 વડે multiply કરીએ, so we have the value 800. That means we can say that your fragment is starting from the 800. The value of HLN is 5. So 5 into 4, 20 bytes નો આપણો header છે. Total length is 100 bytes. Okay, so our data length has 100 minus 20, so 80 bytes. So 80 bytes નો આપણો data છે. So if the first byte is 800, so 800 and the plus 80. Okay, so the last byte number is 879. Okay. Then this thing is about the checksum field that we already seen. That checksum માં કઈ રીતે થાય? તો આપણને 16 मतलब 4 हेक्साडेसिमल नंबर ना આપણે ગ્રુપ બનાવવાના. So 4500 is first group, 28 that is 001 is second group. Okay, 0001 is third group. Okay, 000 is fourth group. 4 and 17 will give you the 0411. The 0 will give you the 000. 10.12 will give you the 0A 0C and 14.5 will give you the 0E05. 12.6 0C06 and 7.9 is 0709. And finally जे कई पण sum આવે, that you have to perform the complement and that will give you the checksum. So that checksum value is added in the checksum part and that data is going to be transmitted. Okay, અહીંયા the checksum આપણે જોયું હતું, તો તે જગ્યાએ આપણું checksum add થાય, header checksum, and then your data is going to be transmitted. So this is all about the IP protocol. In the next lecture, we will see about the ICMP protocol.